So we're going to talk about area of a sector of a circle, and then we'll look at a few applications. So first, just what is a sector of a circle? So you've got a circle, and it's really just taking out like a slice of it. So this is what a sector would look like. And so we want to find the area of these sectors, of these shapes. And so the formula, I'll just give it to you. So it's A equals 1/2 r squared times theta. R is the radius, theta is the central angle in radians, just like arc length, and then A is going to be the area. Okay, so first thing I want to do is just get you used to using the formula. I think that this is pretty straightforward. So I'm going to give you the radius and then the central angle measure, and then we'll just go ahead and find it. So in this case, so I've got R equals 11.5 feet. Theta is 5 pi over 6. So honestly, I think you could just pause the video and do this yourself and then hit play when you think you've got it. So just plug everything in. So, okay, I plug everything in, 1/2 times 11.5 squared times 5 pi over 6. And so then I will just round this to the nearest hundredth because I've got 3 significant digits here. Now, the one thing I do want to point out, this is area, so this is going to be feet squared, okay? All right, so now let's take a look at what if I were to give you the central angle in degrees. Well, if you've been paying attention and you watched my arc length videos, so you should know then we have to convert this to radians. So I would encourage you to convert this to radians and then just see if you can do the find the area, hit play when you're ready. So I've got 125 times pi radians over 180 degrees. So just remember, I like to keep these as simplified fractions and keep them in their fractional form so that I get a more exact answer. And so then I can use my formula, 1/2 r squared theta, plug everything in. So 1/2, 13.5 squared, and then 25 pi over 36. And so now I will get 199 meters squared. Now there's a few different ways that you can go with this. So I could go a slightly different direction and say find the measure in radians of a central angle of a sector of a circle of area 25 inches squared in a circle of radius 2.5 inches. Okay, so this is still asking us to work with this formula, but just notice, so now it's asking us to find the central angle. So it's asking us to find theta. So we've been given the area and we've been given the radius, so we can plug those in to solve for theta. So again, I would encourage you, if you feel like you're understanding this, maybe just pause here, see if you can do this, and then we can meet up. Otherwise, so I've got 25 is my area. My radius is 2.5, and so now what I need to do is just go through and solve for this. So I divide obviously by 0.5 times 2.5 squared, so 25 divided by these two parts here, and I get that theta comes out to 8 radians. Okay, so I have just a few different ways that you can kind of play around with this formula, I guess some application type problems. So the first one I have is, so center pivot irrigation system provides water to a sector shaped field as shown below. Find the area of the field if theta is equal to 35 degrees and the radius is 155 yards. So I just figured you probably have no idea what this is talking about. Maybe you do. So center pivot irrigation, maybe you've like driven past something that looks like this. So the way that these work, they have a center pivot point. So here's that sprinkler system, and so it just pivots around in a circle, you see? So we start here, and then we go, well, whatever way, we go this way, we create a 35-degree angle. And so the radius is 155, and then the theta in this case is 35 degrees. This is, I mean, this sounds like fancy, but really we have all the information that we need to plug into the formula. So I've got my theta, unfortunately it's in degrees, so we're going to have to convert this to radians, and then my radius is 155. So let's first convert this to from degrees to radians. So 35 degrees times pi radians over 180. So remember, I like to keep that simplified fraction, so 7 pi over 36 radians, and then I just plug all the information in. So 1/2 times 155 squared times 7 pi over 36. And so then if I multiply those together, I will get to 7,338 yards squared. Okay, and so for the last one, I think this one's kind of interesting. So I'm gonna encourage you to work alongside me with this one. This is a little tricky, but I think this won't be too much of a problem. So circular sector has an area of 60 inches squared. The radius of the circle is 6 inches. What is the arc length of the sector? So in my other videos, I was talking about arc length. This video, I'm talking about sector area, and now we're combining the two. Okay, so the first thing that we've got to do is we've got to look at the area formula. We start by talking about area. So I just want you to notice like what information we've been given. We've been given the area and we've been given the radius. So you can see just by looking at this that we can solve for theta. So you're going to solve for theta and then you're supposed to be able to figure out arc length from that. Again, like I always say, math is not a spectator sport. If you're trying to get the most out of this video, I would say pause this at this point. I've kind of given you some places to start. So plug these in, solve for theta, and then see if you can figure out arc length. So write out the arc length formula after this. Okay, so I'm going to go ahead and plug everything in. So 60 and the 6. So I can solve for theta. So I'll just divide 60 by these two pieces here to get that theta is equal to 10 over 3 radians. Again, you know me, I like to keep things in a fractional form. And so now I can go to arc length. Arc length is just r times theta. Do I have these two pieces of information? I do, right? So I've got my radius and I've got now, I just found my theta, so I just plug those in. So that's it, that's to finish this. So I'll just have 6 times 10 over 3. That comes out to 20 inches, and so that's it. Okay, so that wraps up this video, kind of a quick one. If this is helpful, always helps me out when you guys like or comment or share. And otherwise, I will talk to you guys next time.